Welcome to ICUDemy, the educational channel of the Critical Care Society of Kenya. Let us remind ourselves of the equation of motion. It describes the peak pressure, which is the maximum pressure recorded during inspiration. It states that the total inspiratory pressure is divided into three components. First, the resistive pressure, which is the pressure required to generate airflow through the airways, calculated as the product of flow and resistance. Second, the elastic or alveolar pressure, which is the pressure needed to distend the alveoli and chest wall, obtained by dividing volume by compliance. Lastly, there is the PEEP, which is minimum airway pressure attained at the end of expiration. To further understand the equation of motion, let's plot the pressure time curve and the flow time curve. To delineate the resistive from the elastance component, an end inspiratory breath hold is applied for a brief period, typically 5 to 10% of the total breath cycle. This pause reduces inspiratory flow to zero, allowing the airway pressure to equilibrate with alveolar pressure, the plateau pressure. The yellow double arrow represents the pressure drop from peak to plateau. This is the trans-airway pressure, also known as the resistive pressure. It should ideally be less than 5 centimeters of water. The white brace represents the elastance pressure, also called the driving pressure. Its upper end corresponds to the plateau pressure, the sum of driving pressure and positive end expiratory pressure. Under ideal conditions, the driving pressure should be kept below 15 centimeters of water and the plateau pressure below 28 centimeters of water. PEEP is the baseline pressure, illustrated by the green dotted line. The minimum PEEP is 5 centimeters of water. Anything above this is referred to as therapeutic PEEP. PEEP is optimized to improve oxygenation and lung compliance while avoiding compromise to hemodynamics. The inspiratory pause is very useful in troubleshooting altered lung mechanics. This waveform, for example, demonstrates increased resistive pressure, seen as a large drop from peak to plateau. This suggests elevated airway resistance, while the elastance component remains normal. In this other case, the elastance pressure is elevated, indicated by a taller white brace. This implies reduced lung compliance with relatively normal resistive pressure. Next, we are going to look at mean airway pressure. It is defined as the time-weighted average of airway pressure over a full breath cycle. Mean airway pressure directly influences the partial pressure of arterial oxygen. It is estimated by dividing the area under the pressure time curve by the duration of the breath cycle. In the next section, we explore the effect of various parameters on mean airway pressure. We begin with a baseline configuration, a PEEP of 5, a peak inspiratory pressure of 15, and an inspiratory time lasting 33% of the breath cycle. This results in a mean airway pressure of approximately 8 centimeters of water. Next, we increase the peak inspiratory pressure from 15 to 18 while keeping PEEP and inspiratory time constant. This has a small effect on the mean airway pressure. In this other scenario, we increase the PEEP from 5 to 8 while keeping the peak inspiratory pressure and inspiratory time constant. This results in a significant increase in the mean airway pressure. Lastly, we increase the proportion of time spent in inspiration from 30 to 60%. This means the airway spends more time at higher pressures, which increases the mean airway pressure. Increasing inspiratory time has the most significant effect on the mean airway pressure. Thanks for watching.